Okay, so for this chapter itself, we're going to learn about your distance, your speed, velocity, and your acceleration. Basically, we're going to learn about how things move and how to use numbers to represent how much they move, how fast they move, and do they change their speed very, very fast, quickly, slowly, or whatsoever. Okay, so first things first is your distance. Now, your distance is basically just the length of your distance traveled, basically how far you move, okay, regardless of the direction. So I don't always need to just move in a very nice straight line. I can actually move up and down, up and down, up, down, up, down like this. This all will be considered as distance. So when we say about distance, basically we just want to know how much did we travel, how far did we travel itself. So you can see over here, if we are going to travel from the red house, so this is your starting point, all the way to your ending here, right? Now, if we take path number 1, okay, you will notice that we will travel 5 kilometers, 5 kilometers, and another 5 kilometers, right? So in total, we are going to travel 5 plus 5 plus 5, 15 kilometers itself. Now, if you notice, if we travel along the dotted path, okay, along the dotted line itself, your distance would just be, because we just travel down here, right? It's just going to be 5 kilometers. So what exactly, how come over here? So basically you can just imagine like the blue color path, there's one patch of grass. You don't want to make your shoe dirty, you want to walk around the bend itself or whatsoever, you will move this red color path. But some people would like to take a shortcut, they just take the 5 kilometers, right? So in this case itself, what exactly is going on here? So the thing is, we're going to learn about something that is very, very similar to your distance. It is its cousin or brother. It is displacement. So displacement is the distance measured in a straight line, okay? And it must be a specific direction itself from the starting point. So this guy is the starting point. So what I mean by this is, for example, if we take the red house as the starting point, right? This is your ending point. So what you want to do is basically you want to grab the starting point and ending point and just draw a straight line through it. So for example, right, like just now the example was like if we travel a distance like this. So if this is your start and this is your end, this is your distance traveled, right? So for your displacement itself, what we're going to do is we're just going to grab a straight line from the start to the end. This guy is your displacement. So basically your displacement, right, is a bit special. So it doesn't care about your direction. It doesn't, sorry, not that it doesn't. It doesn't care about the path that you take. It just wants to know from start to end, what is that specific distance in a straight line. And displacement is a bit special, is that you actually need to say the direction. Am I moving to the right, to the left, up, down, north, south, east, west, northeast, northwest, whatsoever. So you probably will need to be very, very careful which direction is which. So in most cases, we're actually just moving in 2 directions, forward and backwards, left and right. So we will have what we call your positive and negative signs itself. So if your signs are negative, it just means that you're moving in the opposite direction. So you can see in the example here, if you have a positive 30 meters, it's 30 meters in front. Okay, but if you have negative 10 meters, what does it mean? It's 10 meters behind. So your plus and minus signs, right, basically just tells you the direction. Am I moving in the positive direction or am I moving in the negative direction itself? Okay. So in most cases itself, we are moving in a straight line. So typically up is positive, right is positive, left and down is negative. Okay, but you have to take note, or basically we have to write this sentence down, taking whatever direction that we have to be positive. You can choose, or the question will give it to you in terms of a diagram. You can see, like, for example, a car is moving to the right. So you take right to be positive, then you just describe it from there. Okay, so whatever's your initial movement, right, whether you're moving up, down, left, or right, those will be your positive. The opposite direction just be the negative. So in this question itself, this example, you can see, right, if I take right to be positive, if I move from A to B, I will just travel 2.0. And because it's 2.0 is a positive number, this is just 2.0 meters. But if you notice over here, if I'm moving to the left, A to C, because it's to the left, it'll be considered a negative number. So it'll be a negative 1.0 meters. All right. Then for this part over here is you notice we'll actually move from A to B and then B back to A. So you'll notice that we have a positive 2 to the right and a minus 2 itself. So because the plus 2 and minus 2, you actually cancel out, you end up with 0. So what can you learn from this? Is that if you start and end at the same point, you will have no displacement. Okay, 0 displacement if start and end. Okay, let me just write it properly. Your start and end is the same position. Okay, so what I mean by this is you know that your 400-meter track looks something like this, right? So if you started here, you go one round for your 400-meter race. If you start and end at the same position, displacement is 0. Okay, so basically you just need to take note is that if you start and end at the same position, you have no displacement itself, which means because don't forget your starting point and ending point is the same position, right? So if you try to draw a straight line, you don't need to draw because you start and both at the same point, you have 0 displacement. So you can see over here, distance versus displacement, you notice that they have the different definitions, and one is affected by distance, one is not, one is affected by direction, one is not affected. So just take note, both SI unit is meter. Okay, because both of them are lengths, and because they are lengths, they all use meters. Okay, so first things first, if there is no diagram for you, what you can do is actually sketch out the diagram. So you can just imagine you move 10 kilometers to the right. Okay, and then you make a U-turn and you travel 3 kilometers to the left. Okay, so what is the total distance traveled? So total distance is very simple. So normally total distance is we just add up all the numbers. We don't care about plus or minus, we just add them all up. You just add up, you get 13 kilometers, right? Then for your part 2 itself, your displacement is a bit special. So you need to take note. Basically, this is your starting point, this is your ending point, right? What you want to find out is what is this? What is this over here? So you can see actually using a number like the diagram itself, you can see the arrows. You can actually straight away see that, oh, I'm actually taking 10 minus 3 is 7 kilometers. And if you be a little bit more specific, it's 10 kilometers to the right. Okay, because where is your starting point? So your starting point is somewhere on the left, and then where's your ending point itself? You'll be somewhere right of your starting point. So to the right is actually to the right of my starting point. That's what it means by to the right. Okay. The next one is if Chris took the MRT from station A to station B along the dotted line. So which means he took it and he traveled in this path over here. And then he took the same exact path backwards, back home. Okay. So your total distance, very straightforward. We just add up the numbers, right? So it's just 15 plus 15, you end up with 30 kilometers. All right. So, but if you try to find displacement, your displacement will be towards here and then back. So you notice that at the end of his journey, which means that he went all the way back to A. So A to B and then B back to A, right? So where's your displacement itself? It's actually just going to be 10 kilometers minus away 10 kilometers back. So you actually end up with 0 kilometers. Because you move 10 kilometers from A to B, you also move negative 10 kilometers from B back to A itself. So because of this, you actually have 0 displacement because you went back home, exactly the same place where you started from. Okay, so next, let's talk about speed. Now, speed is basically how fast we move, right? So it is actually how much, for example, what it means by 10 meters per second. This is speed, right? It means every second, I'll move 10 meters. Okay. So speed is basically how fast our distance moves with every unit time. So with every second, how much did we move? With every hour, how much did we move, for example? So speed is your distance divided by time. So for some students itself, right, this might be easier for you to see. Distance is speed over time. Okay, better to write it out in words because, okay, so your distance is your speed times time. Okay, so for those who don't know how to use the pyramid itself, if you want to find speed, for example, we will just take this part. And you see distance is on top, right? So it's distance divided by time. On the other hand, I want to find distance, for example, you just take speed. And because these two are on the same level, we just take speed times time. So same thing for time. If you want to find time, you want to take distance divided by speed. It's exactly the same thing. Okay, so because the formula is distance divided by time, it is meters divided by seconds. So it's meters per second. Over here, sometimes you might see the term kilometers per hour. Usually it's for cars or vehicles itself. So you need to know how to convert your units. So kilometers, where you see the per sign, that slash over here, it just means the fraction sign. So when you have that fraction sign itself, just do your numerators and denominators separately, and then just key into your calculator itself to find the actual value itself. All right. Now, let's take a look at what we call instantaneous speed and average speed itself. So the thing is, in real life, when we move, right, we don't always move at the same speed throughout the entire journey. Because when we start to walk, first thing, you might be stationary, and then you suddenly move, then you change your speed, right? So actually, even for any kind of runners during a race, like 100-meter run, 400-meter run, for example, they don't always run at max speed. So at the start, you don't straight away from 0 to max straight away. You don't like start off with maximum speed, right? You will actually need to speed up, make your maximum speed, and then continue. They get tired, and then you slow down and slowly, right? So what exactly is instantaneous speed? It is the speed at that instant. So just imagine you just take a picture. So at that moment where you took the picture, what speed is he moving at? That is the instantaneous speed. So I believe if some of you take the bus, if you go into a bus interchange itself, sometimes you might see there's actually a speed detector. Basically, you can see how fast the bus moves so that they don't actually exceed the limit, because in the bus interchange, there's so many buses, they are not supposed to move very, very fast. So because of this, there's actually a speed detector that can actually allow them to see it. So you can see the numbers flickering from 16, 11, 10, 3, 8, whatsoever. The numbers will always flicker. All right. So instantaneous speed is actually very, very difficult for us to find, because which means that we need like basically super detailed calculations or measurements of that speed in that time. So on the other hand, we have what we call average speed. So this average speed, right, assumes that object is moving at the same speed throughout. So the thing is, so you can just see in this picture, right? He just broke the world record and they gave you this timing or this speed itself, right? So this one, if I'm not wrong, it is time. So if I'm not wrong, this is a 100-meter dash. So we just need to find 100 meters divided by 9.58. So you can see how fast he actually moves. It is, I think, the world record. So when we talk about average speed itself, we actually assume that all the runners, whether you are fast or slow, we all run at the same speed throughout the entire journey. Because sometimes you're faster, sometimes you're slower, sometimes you're faster, sometimes you're slower. Average speed just assumes everything is the same. Same constant speed, not your maximum speed. They are not the same. Okay, and I want you to take note. You cannot, it is not average speed. Please don't write speed 1, speed 2, divided by 2. This is wrong. Please don't do that. This is totally wrong. Don't use this. Okay, if you all use this, straight away 0. So the very important thing you need to take note is this formula. This formula, if you think about it, average speed formula is your speed formula. So this speed is distance over time is actually your average speed formula. So if you really need to memorize one of them, memorize the average speed formula. Okay, so you can see over here, you have time, you have your speed, you have the sorry, you have your distance, you want to find speed. So speed, so you want to find average speed, right? You want to find total distance over total time. Okay, so 100 meters divided by 12.5. Press your calculator itself. You'll end up with 8.0 meters per second. Okay. Then you have the MRT track itself. Now, average speed, right? The total time here includes the time that you use to slow down or even stop. Maybe you want to stop, you go shopping, go eat something, and then you come back and then you travel again. That is included in your total time taken itself. So you can see up here, you have your time, distance from Y to J. All right, and then from J, you stop. Then you move 3.5 from J to C. You want to find average speed. So we know that average speed itself is your total distance over total time. So the very first thing we want to do is ask ourselves, what's my total distance? Okay, so you can see we traveled 23 kilometers and we traveled 3.5 kilometers. That's it. So do take note, put the dot clearly. So it's 5.8 kilometers. And you'll notice that we want SI units. So at this point, I will change this to meters. Because kilometers is not your SI units, meters is our SI units itself. The same thing, what we're going to do is we're going to write for time. So I'm going to move this away. Okay. So let me just... So for time, total time. We move, how long? We move 38 minutes, and then we have half a minute, and then we have 8 minutes. So in total itself, we took 46.5 minutes. Okay, and because minutes is not our SI units, we will convert it by multiplying by 60. So you end up with 46.5 times 60. You end up with 2790 seconds. So just now earlier on, if you all don't remember how to actually convert kilometers to meters itself, we actually just multiply by 1000. So it's 5.8 times 1000. Okay, so now that we have our total distance and our total time, we just need to divide. Okay, so you should end up with 2.0789, and we should round it up to 2SF or 3SF, depending on your school itself. So most schools itself nowadays, they are actually using 2SF, so I'll just follow accordingly. So this is speed, so it's meters per second, and we use 2SF. Okay, so do take note about these values. All right, so average speed, we always remember we need total distance over total time. So the most important thing is ask ourselves what is total distance first, what is total time, then the last step is then we solve. So don't try to do everything in one equation. It'll be very, very, very messy. So as much as you can, try to list everything out nicely first. So label your things clearly, because some of you will just put in numbers, right? Please don't do that. Please fill in your, write down what you're finding, total distance, your total time, solve them, and then you solve your average speed formula. Okay, so next part is actually on your velocity. So just now, if you notice, we are only talking about speed. Speed is about distance divided by time. Okay, so what about displacement? So does displacement have a formula by itself, have a similar formula? Yes, it does. So velocity is the rate of change of displacement, just as how speed is the rate of change of distance. So this one is the formula for velocity itself, and displacement, because displacement is a length, is also meters per second as well. Okay, so all of this you need to all memorize. So the thing is, what's the relationship between velocity and your speed? So just now, displacement is your distance in one direction, right? The same thing, your velocity is your speed in one direction. So they are all very, very closely related itself. So Constant velocity means constant speed in one direction itself. However, the other way doesn't make sense, which means if you have constant speed, you don't necessarily have constant velocity. Why? Because velocity needs direction. So if you change the direction, velocity is not constant. So for example, right, if you move here 10 meters per second, then you move, change direction 10 meters per second. This is constant speed, but not constant velocity. Because velocity needs you to only move in a very specific particular direction itself. So which means for you to have constant velocity, you can only move one direction at that fixed number itself. Okay? So if you have a yo-yo or you just swing this yo-yo around you, right? And you swing it at a constant speed itself, the problem is because my direction changed, velocity also changed. So that is why even if speed is constant, they are not the same. So very important, this one. It's quite a common question that you ask. So what's the difference between speed and velocity? Velocity needs an additional direction, and it's a very, very specific direction. So you need to know which is which. Now for average velocity, we don't use it very, very often. Most of the time, we just use the velocity formula on top. Okay, so this one. All right, so you can see down here, your summary between your speed and velocity, it is the only difference is this part. One is distance, one is displacement. The other one is don't care about direction, it's affected by the number and the direction. Okay. So if you notice down here, acceleration is the rate of change of velocity or speed. Because this one, we assume only move one direction, which is basically your velocity. Because if your object is only moving forward, that means you have the same speed and same velocity because your forward is just the same direction, it's just moving one direction. So basically, your acceleration formula is the rate of change in velocity or change in speed. So this formula down here is your most important one. So this guy is V. This guy is U. So basically, you just need to remember it is final minus initial. It's always final minus initial. You can end up with a negative number, but it just means that you are slowing down instead of speeding up. This one, basically acceleration is speeding up. Speed up or slow down. So you have a positive number, you will speed up. If you have a negative number, you are slowing down. So if I say my object is accelerating, it just means it is speeding up. That's all. Okay? So because velocity is affected by number and direction, if you change number, you change velocity, you will have acceleration. Okay? If you change the direction, you also change velocity, right? You will have acceleration. Okay? So you can see over here, basically, if I increase the number or decrease the number, I will accelerate or decelerate. And if I just change the direction itself, I will also accelerate to the right, to the left, up and down. Basically, you will have some form of direction change. But in most cases itself, we only change your magnitude. All right. So if my speed increase, like I said just now, if you are positive, speed increase, you will accelerate. On the other hand, if your speed decrease, we will decelerate. Now, decelerate itself, right, doesn't mean stop. It means slow down. Okay, it doesn't mean stopping. Now, if you decelerate, there's no deceleration formula, it's just that we end up with a negative value. So if you have an acceleration that is negative, such as this, you just write deceleration equals to negative a. It will just be a positive 5 meters per second squared. So one thing you need to take note is for your units, acceleration, because it is velocity divided by time or speed divided by time. Speed is meters per second. If you divide by another time, another second, it's meters per second squared. All right, so do take note about this. So if you have this over here, what I mean is on top is meters per second, right? And below it is seconds. So if you take meters per second, divide by another seconds, you end up with meters per second squared. Okay, so do take note about this. All right. So let's take a look at the word example. It'll come to you more naturally when we do more questions. So you notice for a lot of this topic, right, speed, acceleration, your velocity and acceleration itself, they are very, very calculation heavy itself. So you need to take note which is which. All right. So if you are still not very familiar, just go back to the first part of the video, rewatch it again, so it will come to you more naturally. So first things first, you have speed, you accelerated, and then after 5 seconds, you travel at this now. So ask yourself, the formula, because you want acceleration, right? Acceleration is v minus u over t. Just remember, v is your final speed, final velocity. So at the end, I am moving at 20 meters per second. At the start, I'm moving 10 meters per second. And what time do I take? I took 5 seconds. So in this case, I will take 20 minus 10 divided by 5. Okay, so 10 divided by 5, you end up with 2 meters per second squared. All right, which means what this 2.0 meters per second squared means is every second, my speed will increase by 2 meters per second. So every second, 2 plus 2 plus 2 plus 2 plus 2. Okay, so initially, or what you start with will always be on your u, will be the right hand side. Okay, and then your velocity will be the one that you end up with. Okay, then over here, let's take a look. So same thing, this is what you are moving initially with. Then you have a deceleration, and this is your deceleration. All right, so do take note about this, and your time taken is 6. So what's your final speed? So same thing, we're gonna write a is v minus u over t, right? You want to find v now. All right, so let's take a look. Ask yourself first, u is 55. What's acceleration? Acceleration is actually negative 4. Because remember, your deceleration is negative 8. Okay, so if it's negative a is 4 meters per second square, a must be negative 4. So time is 5 seconds, 6 seconds. Right, so now all we need to do now is minus 4. It is v minus 55 divided by 6. So minus 24 is v minus 55. V must be, you shift it over, you end up with 31 meters per second. Okay, so you have 31 meters per second, because if you think about it, deceleration, this part, right, means I am slowing down. So if I started with 55, I must have a number that is smaller than 55 afterwards. Okay, so do take note about this.